Welcome back. This is Algebra 1, Section 10.2a, Quadratic Functions. On these quadratic functions today versus yesterday's material, we are going to be adding in, very specifically, a new variable, and that's the variable b. When we add in this variable b, that ends up shifting the graph both left and right. We have some new formulas you're going to see today. The first and most important one is the axis of symmetry, the opposite of b over 2a. So let's go down here and take a look at this first problem. You can stop and pause the recording if you want to take a look at those rules. Our first problem we have is 2x squared plus 4x minus 3. A equals 2, b equals 4, and c equals negative 3. I'm now going to use my equation, the opposite of b over 2a, to try to figure out my values. Well, we're going to plug in our values, 4 and 2, and we're going to see that x equals negative 1. That's my axis. The axis of symmetry is a crucial point in the problem, and so I'm going to draw a line at negative 1 on my graph. This is different than what we did yesterday, because all of our graphs yesterday were symmetrical on the y-axis. This will be symmetrical on that dotted blue line. Somewhere up and down on the dotted blue line lies the vertex. And so for the vertex, I already have one of my coordinates of my point, negative 1. It comes from right there. So now what I'm going to do is I'm going to take that value of negative 1 and I'm going to put it in my equation to find the value of y that corresponds with it. So, remembering when you're inserting a problem and you're evaluating, you use parentheses. Let's insert negative 1 into the problem and see what we get. We plug in a negative 1 in both cases, and we're going to get 2 minus 4 minus 3. Well, that value is negative 5. So, that negative 5 is going to go up here and for the other coordinate of my vertex. Let's plot that. I now need to get a second point on the graph. The second point on the graph that's very easy to get would be the y-intercept. The y-intercept is where x equals 0. Well, if x equals 0, as you look up at the top, you'll see the equation for the y-intercept is 0, comma, c. So, we have the point 0, comma, what? Well, in our case, it's negative 3. So I'm going to plot the point 0, negative 3 on my graph. Now, if you remember from the last section, all points are reflective on a parabola, and so let's go 1 unit away in the other direction and plot the other point. Notice both the red point and the blue point are 1 unit away from the dotted line. I do need 2 more points to finish my graph because I like to have each of my parabolas have 5 points. So I'm going to choose the number 1, just because there's no point that's been graphed in this vertical column yet. So here I'm going to choose the number 1. Well, 2 times 1 squared plus 4 times 1 minus 3. Well, that's 2 plus 4 minus 3. That's the value of 3, and so I have the point 1, comma 3. So I graph that. Just like we did before, that point is 2 units away from the dotted line. So I'm going to go 2 units away from the dotted line in the other direction and graph the reflected symmetrical point. And now I'm going to finally finish up by drawing my parabola. Make sure as you draw your parabola, it has a curve at the bottom, and it goes through each of your points. There should also be arrows on your parabola because there's more off the graph than there is on the graph.